So hexadecimal is a number system that has base 16. So we remember that the binary number system has base 2, the decimal system has base 10, hexadecimal has base 16. There are 16 possible digits, and they go from 0 to 9, and then A is the symbol that represents 10 of quantity 10 of something. B is the symbol that represents quantity 11. C represents 12, etc. So let's just write that into our notes here. That A represents 10. B, C, D, E, and F represent 11, 12, 13, 14, and 15 items. And so with these 16 digits, 0 to 9 and A to F, we can represent any system. It's useful because it is sort of a shorthand to instead of binary that humans understand a bit more. So let's just do an example. We're going to convert hexadecimal back to decimal. So as an example, we're going to do 356, and that's base 16, which means it's in hexadecimal. So the answer to that then would be that we have a digit 3, and we have a digit 5, and we have a digit 6, and this is a positional numbering system. So you should know what that means from lecture 1. And it's a positional numbering system, so we can just, it matters what position each of those are in, and it's going to be multiplied by 16, base 16 to the exponent something. So if we go back to what we have done before and we say, well, this is the number 3, 5, 6, there's a decimal. Then this is the least significant position and then the most significant position. And this represents 16 to the base 0, 16, 1 to the power 1, and 16 squared in this position. So that means that this is 16 to the base 0, 16 base 1, and 16 squared. And this is how we would calculate this answer. So if I were to calculate that, then I'd get 768. Oh, sorry, these are plus. Plus, this is 80 plus 6. Then the answer is 854 in the base 10 system, which is the decimal system. So let's do another example. And that example is 2. That example is 2AF. Base 16, which is a hexadecimal number. So again, I'm going to say, well, there's one digit, there's our other, and then our least significant digit, and the digits are 2, A, and F. So that would be times 16 times 16 times 16, and the exponent is going to be exponent 0, 1, 2, and those should be added together. So you say, well, that's kind of odd. I don't know how to do math with letters in it. That's equivalent to A is how we say a quantity of 10 of something. So you simply substitute in 10, and I do expect you to be able to do this longhand. F is equivalent to 15. All right, so the answer is 687 base 10. Now, if you want to convert decimal over to hexadecimal, unfortunately, we have to do repeated divisions by 16. So let's say we were going to convert 423, which is decimal, to hexadecimal. Then we have to go solution, we would have to go 423 divided by 16, which will give me 26, remainder 7. Take that 7, that's your least significant digit. And there's a few ways of doing this, but I'm just showing you one, and I'm going to be consistent in just showing you one. If you have already learned this a different way where you are from, then feel free to use it. Use the other method. I have a remainder of 10, and then I'm going to take this 1 divided by 16, gives me 0, remainder 1. Now I'm going to drop these down, and my least significant digit is 7. My middle digit is 10, which is represented by an A in hexadecimal, and then a 1. So therefore, 423 in the decimal system is equivalent to 1A7 in base 16, the hexadecimal system. Okay, now let's give one more example. Of converting 214. Then 214, we would divide by 16. We would get 13, remainder 6. Take that as my least significant digit. 13 divided by 16 is equal to 0, remainder 13. And a 13 is represented by a D, and 6 is just represented by 6. So therefore, 214 in the decimal system is equivalent to D6 in the hexadecimal system.